I'm with CIRA, which is the Cooperative Institute of Research in the Atmosphere, part of Colorado State University out of Fort Collins. And I'm on essentially a grant basis to provide, my specialty is actually web mapping support for a small portion of the National Weather Service called the Meteorological Development Laboratory. And with me today also is my coworker, Kevin McGrath, who assisted and also does as part of the visualization team for the map that we do. And people that couldn't be here today, but certainly were part of this, is Tim Kempestry, Dana Strom, and Tyler Wickstrom. Next slide. So outline for today, I'll go over the various types of data sets that we are currently working with in our web map viewer. Discuss a little bit of history. How many went to 2013 FOSS4G? All right, Eddie in the back. So I actually gave a talk about our upcoming viewer then. Back then it was still experimental, wasn't in operations, still had a lot of problems to be worked out. But and then in 2014 was when we actually launched the new viewer. 2020 we moved to the cloud, moved to Amazon Web Services to do all our development there. And just recently, the new version became operational. And we've applied FOSS4G to some of our other data sets, which I've already highlighted at the top. A few viewer features, what's next, and demos if time permitting. Go ahead, Kevin. So the National Digital Forecast Database is a gridded data set that contains sensible weather elements such as temperature, maximum temperatures, cloud cover, dew point, relative humidity. And what happens is that all around the country, in weather forecast field offices, they put together a gridded forecast for their little area, send it off via network, and they're all mosaic together into one grid set. And these are available on one of our servers called the TGFTB server, which I'll get to, and for anybody to use in their applications or in their line of work and business. Go ahead. The National Digital Guidance Database is a companion to NDFD, and it's all model generated, grids as well. And they're used by the National Weather Service forecasters when putting together NDFD. One data set is our air quality guidance, and this includes smoke, particulate matter 2.5 micrograms per meter cubed, dust, and smoke. Also, the national blend of models. So a long time ago, there was only like a few weather models. And you basically knew the characteristics of it and could see, well, it's not going to handle this situation very well. But with increased computational power over the years, forecasters started getting into data overload. Which model am I going to use today? Because there are a lot of which time scale is handling this situation better. So the National Blended Models is an attempt to take essentially the best from various different models and also non-model output, and come up with a starting point for the forecasters in the field to use when they're putting together the NDFD forecast. Go ahead, Kevin. So prior to 2014, and we're talking circa 2002, the NDFD viewer filled a need, but it was only static images. And the way this was put together, so there was limited user interaction. You could have a little bit of zoom type of thing, maybe a little bit of roam, but it would all be in different sectors, and they were already predetermined type of zoom levels and images, and how this was put together was one image per view. And the code was essentially the same for each sector along the way. And so when the process kicked off, for the day, it generated 600,000 images, which is a lot of overhead, a lot of processing time was taken. And in addition, some of our customers also had special requests. They said, well, we're following this area. what you have right now doesn't quite fit our needs. Can you generate images from this area? And the person who did this work at the time, he had to essentially copy all the scripts with just different geographic boundaries and then put them into the processing flow, which consumed a heck of a lot of man hours. Go ahead, Kevin. So in 2011, I got started on the project here to create a new viewer. And many of you are probably familiar with a lot of the tools. I mean, I put out polls for this as far as what you're familiar with. Everybody's probably heard of GDAL, but that was the basic foundation that I started from. And using GDAL, I was able to generate scripting, some scripts to automate the process to georeference the images and put them on Google Map backgrounds. And then OpenLayers came along. The National Weather Service lost its license to use, or didn't renew its license, I should say, with Google Maps. And so we had to find some other way to display the NDFT data with. Well, along came OpenLayers, and it actually opened the door to a lot more things as OpenLayers increased its capabilities along the way. I mean, I think I was using OpenLayers 2 at the time, and I think we're up to 10 now. Go ahead, Kevin. One thing I wanted to do was, if you've not heard of XJS and GeoX, it's basically a GUI framework. And it made the display look a lot more professional, a lot cleaner. XJS is still out there, but the public part of it isn't as accessible anymore. They used to have a community part. But anyway, GeoX was XJS, but with OpenLayers tie-in. And so, such as a layer switcher, a layer selector, was built into that, into a tree object in GeoX. And then we also incorporated PostGIS and MapServer. Initially, what we did was just display the points using the Postgres database, and MapServer would draw the PNG images and retrieve them and put them on the viewer. Go ahead. This is what it looks like now. This is in 2014, we actually launched operationally the new viewer. And this hasn't changed much. I'll maybe show that a little bit later on, hopefully. But we ran into some problems with this, and I'm not going to get into those details. But moving on from there, go ahead, Kevin. We moved into using Amazon Web Services because the problems that we encountered with the initial release of the viewer, we were not able to, we didn't control really the systems that they were on. With moving towards Amazon Web Services, we're now able to use those services, expand speed, whatever capabilities, the different types of Linux operating system. And so it allowed us to explore new possibilities and to get the images out to the public in a lot quicker manner than before. One of the biggest improvements was that initially the rasters were stored in the database itself. And our DB expert, what he decided, he came up with, was that he would only store the metadata in the database, and the rasters themselves were now on a Lustre instance in AWS. Go ahead, Kevin. So this is I'm not going to go into too much detail. I'll just note that, so I know most people are not familiar with GRIB format. It's unfortunate that most weather data is either in GRIB or NetCDF. And GRIB is its entire own, out here somewhere, decoder. Fortunately, the Meteorological Development Laboratory, we actually have our own homegrown GRIB decoder, which is freely available, works on Linux, works on Windows. So anyway, our current processing for this viewer, we go to the TGFTP server, which is public domain. You can go ahead and grab the data. Or it's also on Amazon Web Services, which I'll get to as well. They're converted into float 32 grids, and the top flow is for the forecast raster. For this viewer, we're just using spherical Mercator 3857 for the projection. And They're converted via GDOT to GeoTIFFs. It's just easier to work with. And then once, when the client's up there, where the map server retrieves the raster and the metadata to draw the image onto the viewer screen. On the middle point there is the database guy has come up with a scheme so that with point queries, there's I don't profess to know this, I had to ask him a few times, but suffice it to say that there is a point query scheme going back to the database to retrieve information from the GeoTIFFs. The bottom part, we also put on point layers, and so we extract the selected points that are important to the customers, convert those to CSVs, copy those over the PostGIS point tables, where MapServer will retrieve the information and display those point layers onto the viewer. Go ahead. And this is just the example of the different layers that are displayed in the viewer. We also use Esri base maps at the moment. Go ahead, Kevin. So from when the viewer was first released, and like I said before, that OpenLayers started becoming a little bit more in capability, we started to explore using the expanded capabilities of OpenLayers and also also MapServer to generate, to create viewers of, for different data sets. So in addition, so that's the air quality forecast guidance viewer and the national blend of models. I also want to point out that if you're not familiar with OLX, it's a great library for like widgets and capabilities for layers display, vector point display styling. It's got quite a lot going for it, and it works with the current version of OpenLayers. One thing that, as far as AQ, these two viewers go, that we did not hook them up to a database area, at least not for the most part. There's a few database calls that we were using for points. But rather, what we do is we generate them via some sort of process in the back end, and we create PNG images which are loaded into the browser in an HTML tag instead. We had attempted in these two viewers to also develop with Bootstrap because we want to make these more mobile friendly, more bandwidth friendly, but we're not quite there yet. It worked only part way, and we're going to get there eventually, because you have people out in the field that are using this data, using the viewers to maybe make some decisions, and maybe they're on mobile devices, maybe they're on their phone. So we want to get into the mobile capability as well. Go ahead, Kevin. So this is just an example. So air quality forecast guidance viewer. We have AWS Lambda functions, which retrieve the data from the TGFTP server, processes them using GDAL, converts them to GeoTIFF format, run GDAL dem command on each raster band, and store the resulting PNG images in an AWS S3 bucket. The viewer retrieves those, loads them all up into the tags, and also we use MapServer in this instance to create the point layers. And these are just some examples, some screenshots of some of the various, some of the four elements that we, that are, excuse me, that, I'm going a little too fast. So these are the just thumbnails of the elements that are available on this viewer, such as smoke, ozone, PM2.5, and dust. Go ahead, Kevin. The national blend of models via the whole story, uncertainty, and probability, or what's up, viewer, uses MapServer to create PNGs from GeoTIFFs and vector data files in S3 bucket, and some cases uses OLX for drawing vector images on it. So that, you can't see this too well, and I apologize for that, and I wish I could show you this. But you can see the little circles here on this display. And what this is the National Blended Models has forecast components that go into making the actual forecast. And this gives the forecaster, their pie charts is what they are. This gives the pie charts that are available for OLX, which is really just a styling layer, will show which components or how many components are above the forecast, and which are the same, and which are below. So that's just one capability, one really nice thing about using OLX with OpenLayers. And like I said, just thumbnails of the various type of displays. Go ahead, Kevin. Many of you have already seen, in other viewers, some commonality between, what's the knobology, if you will. The two I'd like to point, a couple I'd like to point out is we have mouseover readout value. This takes the color of the pixel from the mouse and correlates it to a lookup table for what the value is at that point. We do have point probe display also that opens up in a separate time series or NBM, but when you click on a map, you'll actually get the value. It either goes back to the database or it goes back to the data itself, depending on the viewer. The other thing I wanted to point out was the forecast time slider, which is essentially a poor man's looping animation type of thing, but you can scroll with the slider, you can move it up and down and see how everything flows. Go ahead, Kevin. Some additional display features that we developed on WasUp were thresholding via HTML canvas. This allows a forecaster or a user to actually slice out in colors and highlight which parts of the color values are of importance. So if you are looking at, say, temperatures above 100 degrees, you would use this function to just remove everything, remove all the colors that are less than 100 degrees, and then you could see where everything is at 100 degrees or above. Comparison window via OpenLayers Spyglass. If you go to the OpenLayers example page, there's what's known as the Spyglass, and you can hover over and get a different type of imagery or display that might be underneath it, such as terrain, or I think there was one for vegetation index. Well, we use this to create a window, a small window here, which is actually of a different data set. So you can actually see the data set that you're displaying, such as NBM, and how that compares to, like, say, MDFD. Go ahead, Kevin, I'm just gonna go ahead. So what's next? We're starting to go on with React.js and also Next.js in the server side to generate for our UE, and also to kind of like refactor how the code's all put together in the React components instead. Go ahead, Ken. Oh, I'm sorry. I mentioned this. We're continuing to try and make this more mobile and bandwidth friendly. Go ahead, Ken. If you are interested in NBM, air quality, where to get data from, the two at the bottom, I'm sorry, yeah. The two at the bottom, actually, like NOAA NDFD and NOAA NBM, those are AWS links to the data that we store in buckets. And then you can actually go, if you're familiar with QGIS, of course, you can actually use QGIS to link into those to go ahead and get the data. The data is freely available. There's no charge for it. And the bottom one, if you're really interested in learning about this, that's MDL's homegrown degrib executable that you can link to. There's tutorials on how to use it. It's command line as well as GUI interface. And we use it in scripting mostly. Go ahead, Kevin. Okay, I'm going to drive from this point. Oh, I want to execute now that. We are fortunate today. So this is the current NDF viewer, and this is Hurricane Francine forecast. And I think it is valid. This might have been an older forecast, but this is valid as of 5 p.m. Central Daylight Time. And as I mentioned before, this has this slider that you can step through. You can see the forecast, how it evolves, or you can go directly to some sort of time period. I've got 10 minutes. The reason it's a little disjointed is that there are areas of responsibility. So like this one, there's one agency that puts out a forecast in the lower Gulf, but Louisiana National Weather Service forecast puts a little bit slightly different, and so it's not completely, doesn't completely fit together properly. That's just the way things work. But I just wanted to point out, if you can see this, we do other things like for Alaska, Hawaii, Guam, Puerto Rico, the tropical Atlantic, tropical Pacific, Micronesia, and Oceanic. And this drop-down shows, I hope you can see that. This drop-down shows all the forecast elements for the CONUS that we put images out for. So if I wanted to switch to maximum temperature, and let me see if I can zoom out here a little bit. And also, I mentioned this before, but here's point probe. So it'll give the value at the top and also something that's related, plus links back to some of the National Weather Service products that you can get on their page, on the local office page. And real quick, this is the air quality page. I'm highlighting in this one bias corrected PM 2.5. Hey, Kevin, never mind. Let's see if I can get this here. I mentioned about the time slider, so you can actually see a little bit more about the flow here. And then just one more, because probably all of you remember last year's smoke wildfires. There we go. So this is column integrated smoke, and this actually really does show a lot better. Oh, I'm sorry. I pushed up a point probe. You can actually see from here that some of the wildfire in Oregon and Southern California, some of the starting places, locations for them. And let's see. I don't know if you want the last slide up or not, the data slide up or not, but that's all I have. Thanks for attending. I appreciate it. Any questions? Yeah, go ahead.
Yeah, access to storage and the storage versions.
Actually, you can. So let me show this little slide here. So the NCEI that you see there, it's like the middle of the links. NCEI there has archived data. I can't remember what it stands for. It's like National Climate Environmental something or other.
You know how far back
it goes back fairly far, but I don't know. I don't know exactly how far. You can go to the link and they'll tell you how far back it goes. It varies on the access that you want to get to. So, in other words, there's HTTPS, but there's also I think there's a thread server as well. So, and that it depends, the amount of historical data depends on the server that you're going to.
Pat. Well, that meant you had a friend saying a minute ago, where y'all aggregate data also from the NWS on that setup?
You mean
the database center?
No.
Don't will be database or something?
We don't own that viewer. I mean, there's.
Well, you might point in RSSB to aggregate the information from the.
No. None on this one. Oh, yeah.
What is it about your for the action?
I'm sorry, say again?
What's the your consideration to move the app to React next year?
It's just,
Ruby, what?
yeah, go ahead.
Sorry. Yeah, I'm just asking, like, why moving to React in Next.js?
Sure. It will allow us to essentially, you want to take that one, Kevin?
It's going to bring tools, for example, some of our widgets kind of defined once, but we can repurpose them. It's kind of more of a component-based architecture. It'll bring a lot of tools like automatic device sensing, whether you're in a mobile. It'll bring touch capabilities that in our current JavaScript, jQuery, Bootstrap architecture would just be a lot of extra coding that we'd have to render sentence.
Anything else? Yeah.
And especially if, first it's really awesome to see what's happening behind scenes, and then you out to this, spent some time working with great bit.
Mm-hmm.
Seems to be sort of universally accepted as that. I'm just curious if there has ever been discussion about kind of like distributing as geotip instead, for example.
There have been recent discussions. Actually, the NBM, I failed to mention this, the NBM data that's publicly available is in GeoTIFF. But we've had these discussions, and we're, kind of like, that's below our pay grade type of thing. So, we've had the discussions. We actually, I think, wanted to put NDFD in GeoTIFF as well. But it's still in GRIB format. So, I mean, that's been universally accepted as weather data format for a long time.
Help with that, NGL does have a open source project. It's on GitHub, Grid 2.io.
Oh, that's right.
On that, but it allows you pythonically to be able to read GRIB files, write GRIB files, bring it in at X, or at least it.
And I do know QGIS, of course, because it's based on GDAL. You can bring in GRIB data there as well. Anything else? Yeah.
Maybe about weather state,
About what?
weather alerts.
Weather alerts. No, I mean, I know about weather alerts, but we don't. That's not our department. Hate to say that, but it's not.
You just know where to get chase.
Oh, well, the National Weather Service does have its GIS page that you can get shapefiles from.
Yeah, but those aren't free, like,
Yeah, I know, but I wonder if SPC would. Do you think SPC might do that too?
doesn't issue getting.
Oh, are you talking about warnings or are you talking about watch boxes?
The watch box.
Yeah, so SPC might have those on KML format on their page. I'm sorry, the Storms Prediction Center. spc.noaa.gov. Believe it or not, I don't think they do. I know. To me, I think that there are several. I think the National Weather Service is behind personally on, unfortunately, Geospatial because there's still KML out there. There's still animated GIFs, and there's, like I said, GRIB and not GeoTIFFs, which is a lot more. I think people use a lot more out in the geospatial world. But yeah, I think they're in KML as I recall. But you can go look and see. I don't think they're in GeoJSON.